All right, folks, here's number 5 on the homework. This is on the back of the homework, talks about logs. This problem was requested by a couple folks, so I thought I'd put the video up. So we got y equals absolute value log base 2 of x plus 1 minus 6, close the absolute value. First thing they want us to do is what if the transformation's done? The minus 6 tells us to go down by 6. The plus 1, this is inside the argument, so we're going left by 1. And the absolute value bars, of course, make all the y values positive. So first thing I want to do is find out where the asymptote is. Two ways to do this. On the parent function, the asymptote is at x equals 0. We've gone left by 1, so the asymptote must be at x equals negative 1. That's one way to find the asymptote. The other way is to take the argument and set it equal to 0. So x plus 1 equals 0, minus 1 on both sides. X equals negative 1. That's the vertical asymptote. I came over here, just went ahead and drew that vertical asymptote down the page. Next thing I'm going to do is find the x-intercept. Plug in 0 for y. Absolute value bars can be dropped here because 0 is neither positive nor negative. Add 6 to both sides. 6 equals log base 2 of x plus 1. 2 raised to the 6th power. Remember, the base raised to the power equals the argument. The base raised to the power equals the argument. 2 to the 6th power. 2, 4, 8, 16, 32, 64 equals x plus 1 minus 1 on both sides. 63 equals x. So the x-intercept is 63 comma 0. Here we have it. Now I see no reflection, so the graph should have come from down through the point, but we can't have negative y values because we have the absolute value bar, which is why the graph comes from upstairs, touches the point, and then bends back up, and it looks like an absolute value. It's not actually a v, it's absolute value. Now there might be a question as to how to find the two other points, and let me go ahead and record a second video on how to do that.